Good morning, everyone. This morning we'll be looking at orthogonal cycles, intrigue, and analytical. Attendance is okay. We'll be looking at orthogonal cycles. When a cycles is said to be orthogonals, then we also saw one or two examples. Is that clear? So now, when we say orthogonal cycles are talking about two cycles that intersect at a rectangle, triangle. Is that clear? Two cycles that intersect a right angle. Two cycles. Let's have a sketch orthogonal cycles. That is 1 to 2. You know? Orthogonal cycles. Orthogonal cycles. You know? Okay. So let's look at what I was trying to explain. Two cycles that intersect at a right angle, we refer them as orthogonal cycles. Is that clear? So let's have a sketch. It's a cycle, we assume not perfect. So let us have a right angle. You can now see that they are intersection. Look at their intersection. Look at it here. So this is we assume that this is the center 1, center 2. Amen. Are you following? So this is at point P. So you can now see that their intersection. These are two cycles, and their intersection at they intersect at what? Right angles. So it means this is called an orthogonal cycle. Is that clear? Any question? Are you following? Are you following? Do you understand? Okay. So far, so good. So let's proceed further. So orthogonal cycles. Two cycles which intersect at right angle is called orthogonal cycle. Do you understand? Two cycles intersect at a right angle is called an orthogonal cycle. Are you following? Okay, let's proceed further. Let's proceed further. If you can understand this, let's move further to consider cycle that touch cycles that touch. Oh, we have cycles let's have it this way. Okay, this is center 1, center 2, and this is radius R1, R2. I know the drawing is not perfect. You can draw it with your compass. Okay. These two cycles, we refer them as externally. Because just look at this. They touch each other externally, two of us. So if we want to make it cycle, just have it in this one. You can now see. So these are externally touched cycles. Do you understand? So when you are asked, when is a cycle said to be externally, you can give this. Is that clear? Okay. So these are externally touched cycles. Then let's consider cycles that are internally touched. Let us have cycle Can you see now? Okay. Let's assume that. Are you seeing now? This is C2, C1, right? Oh, C R1, C2, R2. We can refer this cycle as internally. This is called what? Internally. Are you following? This is called internally. Amen? This is called internally. So take note of this. Please don't forget to share and wake up your friends to be part of the class. so that no one will be left behind. Okay, I want you to like, share, comment. It's very important. Share it with your friends on any of the platform you are. Let's proceed further. Let's proceed further. Amen. Yeah, let's write. If the cycles touch externally, that's right. If the cycle touch externally, then the distance between their center, then the distance between their center the distance between their center, amen, their centers is the sum, amen, of their radar, right? The sum of their radar. Or let me explain this. Look at, if the cycle touch externally, then the distance between their centers is the sum of their radar. So, can you see now? This is the center of this cycle, and this is the center of this cycle. So the distance between them is the sum of their radar. That is, it means that these cycles, since they touch each other externally, so it means C1, C2, all square is equals to R1 square plus R2 square. So it means C1, C2, all square is equals to the square root of R1 square plus R2 square. That is what it means. Do you understand? Are you following? That is what it means. Do you understand? Right? Are you following? Oh, somebody is telling me to come. Francis, Destiny. You mean you are not following? What this statement is talking about, look at it. This statement is talking about these two cycles that touch each other externally. That if the cycle touch externally, that is this illustration, then the distance between their centers is the sum of their radars. Where we say, look at it, a radius is talking about 1. But when we say radar is talking about what? 2. It means it's talking about this radius and this. Do you understand? So this implies that, as I was saying, this means that this is center one of this cycle, two of us. Then this is center another cycle, center two. Amen. So it means mathematically is telling us that C1, C2 square. That is okay. The square affects both of them. So let's do it this way. Is equals to the sum of their radars. It means r1 square plus r2 square. Then it means we are talking about the distance. The distance between the two centers is equals to this. Go back to your Pythagoras theorem. That is what it means. It's trying to explain. So now here is C1, C2 is equals to, you square both sides. It means we are going to have it in this one. R square 1, R1 square plus R2 square. Do you understand? Are you following? Are you following? Do you understand, right? Okay. Let's proceed again. And if they touch internally, then the difference between their center is the difference between the distance, sorry. And if they touch internally, then their distance between their centers amen, is the, now this time now is talking about the difference is the difference between their radar. Is the difference between their radar. Is that clear? I will explain it. I'm going to explain it better. Okay. So please take notes. Do you understand? So what this thing is trying to say, it means if these two cycles, look at them here, they touch internally, two of us. So now, and if they touch internally, then their distance between their centers is the difference between their radar. So it's just talking about, this is center 1 and this is center 2. So it means the same thing applicable. You know, this other one is their sum. So here means that our C1, C2, all in brackets is equals to R1 square minus R2 square. Then our C1, C2, all in brackets, this is equals to, square root of r1 square minus square root of r2 square. So you can now see the difference between this and this. This one is talking about the sum of the sum of their radar. Then this one is talking about the difference between their radars. Can you see now? So in case you are asked to differentiate between the internally touched cycle and externally touched cycle, at least you'll be able to tell this. If you can tell this, or you write out this, at least is a good knowledge of you. Is that clear? Do you understand? Do you understand, right? Okay. Any questions so far? Please, if you have any question, drop it in the comment section. If you have any question, drop it in the comment section. Any question? So, can we proceed, if I may ask? Can we proceed? We can proceed, right? Okay, let's consider some examples. Yeah. Example says, show that the two cycles example show that the two cycles x square plus y square or minus 16 x minus 12y, amen, then plus 75 equals to 0, and 5x square plus 5y minus 32x plus 24y plus 75 equals to 0. Amen. I want to look at this problem together this morning. Okay. Okay. So far, so good. It's simple as ABC. Is that clear? Touch each other. So let's write solution. We said we should prove or show that the two cycles, this x square plus y square minus 16x minus 12y plus 75 equals to 0, and 5x squared plus 5y minus that's 2x plus 24y plus 75 is equals to 0. So these are the two cycles, and anything we are doing, thank God that you've been taught the equation of a cycle. It's true of us when to compare the equation of a cycle when you have been given an equation. So they said we should show that the two cycles touch each other. So if the two cycles touch each other, what we need to do is, you know very well, whether does not, here it is not specified that we should either externally touch or internally, two of us. So this is how we are going to consider this kind of problem. Please listen attentively. Is that clear? It's very important. Listen attentively. So far, so good. What we need to do here is we have to compare this first cycle, equation of a cycle, x squared plus y squared minus 16x minus 12y plus 75 equals to what? 0. Now, what we need to do, we have to compare it with what? With the equation of a cycle, that is x squared plus y squared plus 2gx plus 2fy plus c equals to 0, because the two cycles that touch either internally or externally is talking about, one is talking about their radars, two of us, that is R1 plus R2, two of us is some of their radars. Then the other one is talking about the difference of their radars, two of us. So it means there is need for us to look for the radius. So the radius, okay, I'm very sorry about the network. The network here is fluctuating, so I'm very sorry, very sorry. Amen. Okay, so as I was saying, I said since we should show that the two cycles, this and this, touch each other. So what we need to do here is, since cycles that touch internally or externally, one of them is talking about there are two radars. The center of their two radars is equals to the sum of their two radars. Then the other one is talking about the difference of their two radars. So it means it will require us to consider the distance, the radius, and the equation of a cycle. As long as the equation of a cycle is concerned, we need R equals to g squared plus f squared minus c, all in square root. So how can we find this radius? We know, we'll be taught in class that whenever we have equation of cycle in this form, it means we need to compare it with what? the general equation of a cycle, true or false, then that will enable us to find our center and what? The radius. True or false? True or false? It's true, right? So let's look at it together. So here, if we compare here, we have 2gx is equals to minus 16x, and 2fy is equals to minus 12y, right? Then here c, and c is equals to what? 75, amen? Okay, since c is equals to 75, so this implies that let's obtain our g. If we are to obtain our g, we divide through by 2x, true or false. So g will now be equals to minus 16 all over 2x. Then the same thing applicable, our f, obtain our f, we divide through by 2y, right? So f will now be equals to 12y all over 2y. Excuse me. Do you understand? Are you following? Okay. So if you are following, it means here, it means we don't need the prophet to tell you this 1, 8. So our g is equals to minus 8. But mind you, the center is what? Negative, right? So here is negative. So our g is supposed to be what? Plus 8. True or false? Then here, this 1, this 6. So f is equals to what? Minus 6. Since the center is negative, so here is f is equals to plus 6. True or false? Do you understand? Are you following? True or false? It's true, right? Okay. So if you agree with me, it means the center C, that is f, g, l, which is equals to center C, is equals to 8, 6. Amen? Okay? Then, what we need to do is, what are we going to do? We have obtained our what? Our G and F, also C, and C is equals to 75. So our arrow will now be equals to the radius, now be equals to square root of G squared plus F squared minus C. Then this is equals to square root of G is what? 8, right? So 8 squared. F is 6, right? 6 squared minus C is 75, right? Okay, help me compute this. And somebody should tell me the answer. 1 mark for that. The first two people. I give you, that to give you 1 mark. waiting. Yeah, what is the answer? It's going to give you 25. Okay, Bello, Musa, and Mahmoud, Abdullahi, Musa. I think you are the two I'm saying. So remind me, Justice Akpa, okay? 1 mark. Remind me in class. Just remind me. Is that clear? Remind me in class. Are you following? Remind me in class. Okay. So you said this is what? 20. Okay. Let's do it together. Our R is equals to 72, right? Here is 72 plus 36 minus 75. True or false? True or false? So here we are going to have 1/8, right? 1/8 minus 75. 1/8, right? This one, 8 times, oh, sorry, 64, sorry. 64. This is 100, right? Then this is equals to square root of 25. Then our R is equals to 5. Amen? Are you following? Yeah. Do you understand? Okay. So far, so good. Then that is that. So let's consider this other one. Let's also consider this other one. This other equation of a cycle plus 5y minus 32x plus 24y plus 75 equals 0. So it means with this, you don't need the prophet to tell you. So our 2g is equals to, 2g is equals to, no. What we need is, we have to transform this in the form of equation of the cycle. True or false? Do you understand? So what are you going to do? Look at that equation. Very good. Okay. we have to transform it into equation of a cycle. So what we do, yeah, look at it. It says it has constant, yeah, true or false. So we have to divide through by what? 5. Divide through by 5. So it means here will now be x squared, this is y squared, plus y squared minus 32x all over 5 plus 24y all over 5 plus 75 all over 5 equals to what? 0. Amen? Do you understand? Do you understand, right? You understand, right? Okay. So this implies that, look at it. This implies that our G, 2G, is equals to minus 32x all over 5 and 2fy is equals to plus 24y all over what? 5. Then our C will be equals to 75 divided 5 is 15, right? Because 15 times 5 times 5, 25, carry 2 times, yeah. So now what are we going to do? Let's find G. So in the process, it means our G is now equals to, our G will now becomes minus 32x all over 5 divided 2x. So if you can see what I am saying, amen, this is the same thing as minus 32x. Note that there is an invisible one here. So all over 5 times 1 all over 2x. So 2 can cancel itself, 2x can cancel itself. 2x to minus 32 is 16, 2 of us. So G is equals to 16 all over 5. Then, amen, likewise, this, our F. How can we obtain our F? Is divided by 2y. So F now be equals to 24y all over what? 5 divide 2y all over 1. Then our F will now be equals to 24 all over. By the time we convert the division to multiplication, then this one will come up, this one will come down, 1 all over 2y. Amen. I hope you are following. Do you understand? Do you understand? Okay. Okay. Do you understand, right? So if you can see what I am saying, so this implies that you don't need the perfect 2y to itself, 2 y to 24y is 12, right? So our F is equals to 12 all over what? 5. But note that the center and G is equals to 16 all over 5. Note that the center is always what? Negative. So here is minus F, here is minus G. So our F will now be equals to minus 12 all over 5 and G will now be equals to minus 16 all over what? 5. Take note of this. Take note. Are you following? Do you understand? Any question before we proceed, please drop your question in the comment section. Very important. If you have any question, any question, any question, please always like, comment, and share. You can send me stars. Very important. Okay. Yeah. So let's move further to consider it means this is the first radius 1, right? Then, excuse me, then here will be R2 is equals to R2 is equals to square root of G squared plus F squared minus C, amen? Then this is equals to, what is G? G is minus 16 all over 5 square. Then plus F is what? Minus 12 all over 5 all in square. Then our C is 15, right? Minus 15. So somebody should solve this, and I'm going to give you 1 mark. The first 3 students that will solve and tell us the answer. Is that clear? Yes, I'm waiting. Please do that. Somebody should do that. Somebody should do that. Yeah, what is the answer? The radius is what? Oh, Mahmoud Ablahi. Yeah, you are right. Please remind me. You have gotten 2 marks. Remind me in class. Is that clear? Is 1. Yeah. So it means our radius 2 is equals to 1. So now let's go back to the cycles that touch. You know, one of them says that, can I take out this part? Let me take out this part, right? Cycles that touch externally says that the center 1, center 2 is equals to the square root of what? Oh, sorry. Center 1, center 2 is equals to what? The sum of the 2 radius. Sorry, yeah. This is what it means, please. This is what it means. Please. This is what it means. No square root is attached, please. No square root is attached, please. Just take note. Is that clear, please? This is what it means. According to, go back to that statement. Sorry about the mistake. Go back to that statement. I think it's oversight. So now their sum is what? R1 is what? 5 plus R2 is what? 1. This is equals to 6. True or false? True or false? True or false? Look at it. True or false? It's true. Their distance. So now, let's try it. If there are distance between the sum, you know that these two radius gives us 6. So let's also consider the center. The center here is 6, comma what? 8, comma 6, right? So let's try the center as C1, C2 is equals to 8, amen, is equals to the square root of, amen, the square root of, that is, there are two distance. There are two distance. It means square root of G1 minus G2 all in square plus, mistake note, plus F1 minus F2 all in square, right? So our G1 here is what? 8. So we want to know, it means the square root of 8 minus our G2. This is G1, F1, then G2, F2, right? So G2, okay, look at it here. G2, F2. G2 is minus 16, right? So minus 16, it means we are supposed to be plus 16 all over 5, all in square, then plus F1. F1 is what? Open bracket 6 minus plus, it will now come to what? Plus 12 all over 5, all in square. You agree with me? Do you agree with me? Oh, no. No. Sorry, please. Here is supposed to be minus. There's a mistake here. Please let us correct it here. From this, here is supposed to be minus, not plus. So I think we made a mistake here. Here, supposed to be minus 16 all over. Then when the center is negative, so negative times negative, here is supposed to be plus. So here is supposed to be plus 16. Yeah. So it will not affect this minus. Then here too, since minus 24y, so this is what we are supposed to have. we are supposed to have f is equals to minus. So minus. So since the center is negative, the center is negative, minus times minus here is plus. So here too is minus. Please correct that mistake. Please quickly correct the mistake. Quickly correct the mistake. Excuse me. Quickly correct the mistake. Sorry. So it means here C1, C2 is equals to 40, right? Take the LCM minus 16 all over 5 all in square, then square root, then there is 30, right? Minus 12 all over 5 all in square root. Then this is equals to, this one will be what? 24 all over 5 all in square, then plus this one will give you what? 38, right? No, 18 all over 5 all in square. Am I right? Am I right? So what you need to do is somebody should expand and take the square root of this. I'm going to give you 1 mark. It means what the cycle is trying to explain is this. Please take note. That is the center, the distance between the two centers. If they are equal to the sum of their radians, it means it is known as what? Externally touched cycles. Is that clear? So after doing this, you can now see that the two radians, R1 plus R2, gives us what? 6. So now the distance between the two centers, the distance between the two centers, you know the distance formula is nothing but this x1 minus x2 all in square plus y1 minus what? Y2 all in square, two of us. So since we are talking about center, we now convert this to g1 minus g2 plus f1 minus f2 all in square. Can you see? So this is what we use. Please take note. Are you following? Okay. Yeah. So as you can see that this is equal to this. So that is that. Please, thank you for your time. Those who are in civil engineering or want to start calculus. I love you guys. Don't forget to like, share. Attendance is mandatory. Is that clear? So let us calculus class. Is that clear? Please don't forget to write in the attendance after 10 minutes. It's very important. And make sure you should inform others to be part of the class. Are you following? Okay. So far, so good. Let's move further to consider calculus. Amen. Okay. Amen. So far, so good. 211. We'll be talking about talking about exponential functions. Exponential functions. When we say exponential functions are functions. They are which contain they are functions which contain exponential x exponent. Then this is called where this is called an exponent. Amen. An exponent. So that is called an exponent. Take note. An exponent. Okay. So please like, share, comment on it, and share it. Inform your colleague that we have started. So that is the definition, the brief definition of an exponential function. You know, at the power series exponential function, okay, yeah. So let's use some example to consider. Let's use some examples. Amen. If examples, if x is equals to 0.1, evaluate exponential x. You know, it's simple as ABC. Please, your calculator is being able. So it means what you need to do here is, since x is equals to 0.12, so our exponential x will now be equals to exponential 0.12, and somebody should hint us with the answer. Tell us the answer. Tell us the answer. Please invite other of your colleagues to be part of this class. It's very important. Somebody should tell us the answer. Or what is the answer? Exponential 0.12. Exponential 0.12 will definitely give us 1.1275. This is what we are going to have, 1.1275. This is what you are supposed to have. Amen. So far so good. What if, another example, is if x is equals to 0.18, amen, and then you are asked to evaluate evaluate 3.72 exponential x. Amen. And you are asked to evaluate 3.72 exponential x. It's simple as ABC. It's not difficult. What we need to do here is write solution. Amen. So it means our x is equals to 0.18, then exponential, then 3.72 exponential x will now be equals to 3.72 exponential 0.18. So find the value of this. Press your calculators. Find the value of this. Find the value. Find the value of this. So if you find the value of this, this will give us exponential 0.18 will give us 1.197217. 1.197217. It means 3.72 times 1.197217. Amen. Hope I'm right. 197217. Yeah. So I want you to use this to multiply this. What are you supposed to have? Please do that quickly. Use this, use your calculator. Use this to multiply this. I'm going to give you the first 3 persons. I'll give you 1 mark in class. Please, very fast. I'll give you 1 minute to do that. I give you 1 minute to do that. 1 minute to do that. Multiply. Oh, peculiar. Daniel, 4.453, right? 4.453. 4.45. Yeah. Please remind me in class. This will give you 0.18. Will give us 4.4544. Yeah, this is what you are supposed to have. 4.454. Please remind me in class. I'm going to give you your homework. Is that clear? It's very important. It means you are following. You are active. Oh, another person, Abraham Emmanuel, and Benson, Wisdom Benson. Please remind me in class. Is that clear? Okay. So that is that. So in case you come across all this in a test or exam, you'll be able to evaluate with the help of what? A calculator. True or false? So let's move further to consider a brief on Taylor series. Amen. Just a brief on Taylor series. Is that clear? As long as exponential, power series. As long as exponential function is concerned. So, the value of exponential x can be calculated to any required degree of accuracy since it is defined in terms of the following power series. Is that clear? So now, as long as power series is concerned, power series is concerned, I'm not going to touch deep, but you will meet it in HND. Power series is concerned. This exponential x is always in this form: 1 plus x plus x raised to power 2 all over 2 factorial plus x raised to power 3 all over 3 factorial plus x raised to power 4 all over 4 factorial, then plus x raised to power 5 all over 5 factorial plus da da da. Amen. So as long as power series is concerned, as long as power series is concerned, the definition of exponential x, the power series is this. Just take note. Is that clear? The definition of exponential x in power series is this. So that is that power series. So now, if you are asked to evaluate or do one this thing, or do one. Okay, as long as okay, if you have been given this and if x is equals to 1, you don't need a prophet to tell the two of us. It means our solution, our exponential 1 now becomes 1 plus, anyway you see x is what? 1, right? 1 plus 1 square all over 2 factorial plus 1 raised to power 3 all over 3 factorial plus 1 raised to power 4 all over 4 factorial plus 1 raised to power 5 all over 5 factorial plus da da da. It continues. Is that clear? Do you understand? Because our x is 1, isn't it? Isn't it? Okay. So if you agree with me, this implies that note that go back to your logic and linear algebra. You did combination, permutation and combination, two of us. So if we have 2 factorial, this means 2 times 1, 2 of us. Then if we have 3 factorial, this means 3 times 2 times 1, 2 of us. I'm trying to remind you of what you're supposed to know. Then 4 factorial means what? 4 times 3 times 2 times 1, 2 of us. And 5 factorials means 5 times 4 times 3 times 2 times 1. So if you see 6 factorial, what does it imply? This means 6 times 5 times 4 times 3 times 2 times 1. Amen? Do you understand? So that is that. That is that. So far so good. So if you agree with me, it means here will now be exponential 1 will now be 1 plus 1. 1 raised to power 2 is greater than 1 all over 2 times 1 plus 1 raised to power 3 is greater than 1 all over 3 factorial is 3 times 2 times 1. Then plus 1 raised to power 4 is the same thing as 1. Then 4 factorial is this times 2 times 1, 2 of us. then plus 1 raised to the power 5 is the same thing. 5 times 4 times 3 times 2 times 1. Amen. Then plus da da da. Yeah. So this is equals to 1 plus 1, 2, right? 2 plus 2 times 2, 2 times 1, 2 plus 1 all over 2 times 3 times 2, 6 times 1, 6. Then plus 1 all over 4 times 3, 12, right? Times 2, 24 times 1, 24 plus 1 all over 5 times 4, 20. 20 times 3, 60. 60 times 2 is 120 times 1 all over 120, then plus da da da. True or false? True or false? True or false? It's true, right? Are you following? Do you understand? I am not saying electrical students here. It's only agri-chemical. I'm not saying them. True or false? It's true, right? Okay. So if it is true, then I want you to compute that. I want you to compute that. I want you to compute that. So at the end of the day, you are going to have the final answer. I want you to compute it. The final answer will give you 2.71828. The final answer will give you, this is equals to 2.7128, right? Am I right? 718, sorry, 828. This will be the final answer. Anyway, I told you that I will not go deep in power series, but you meet it in HND. So I just try to do the simplest parts in power series. So this is how, if x is equals to this is how you are going to compute the power series. Is that clear? So let's now proceed further to consider differentiation of exponential functions. Are you following? Differentiation of exponential functions. Okay. Do you understand? Please take note. Make sure you write it inside your note. It's very important. Very, very important. It's very important. It's very important. Okay. So let's clean this. Sorry. Differentiation of exponential functions. Let's know how to differentiate exponential functions. Is that clear? Let us learn how to differentiate exponential functions. Are you following? Let's learn how to differentiate exponential function. Okay, now, let's first define what differentiation is all about, right? Let us define a function mathematically. This is a function. This means that this is a dependent variable, right? This is an independent variable, amen? Independent variable. Then this is a constant, and this is called power or index, amen? Are you following? Or index, power or index. Okay, so if you agree with me here, it means here is y equals to ax raised to the powers of n. So let us define differentiation mathematically. If you are asked to, if y is equals to this is a function, and it said find dy all over dx, right? It's simple as ABC. It is not difficult. It means y is equals to ax raised to the powers of n. Please don't write it this way. Y is equals to axn. This and this does not look alike. Please take note. Is that clear? This is axn. Why this is ax raised to the power what? N. Take note. Very important. Okay. So for us to differentiate this function with respect to x, it means y is a function of x. Is that clear? Children and parents, depends on the parents, two of us, to look at it. The children, two of us. Okay, so now what we need to do here is the reason why it is all over the x is because the independent variable is x, right? So what we need to do here is use this any constant that is here. The constant here is what? A. So a times x is n is a n x raised to the powers of this power minus 1. This is the formula for differentiation. Amen? Are you following? So anything we are going to do all through, sorry about the network, all through sim plus it is not, is it showing now? Is it not showing? Somebody should answer me. Is it showing now? Okay, it's showing now. Thank you. Okay, yeah. Okay, so you now know this. As I was saying, I said for us to differentiate this, it means it will be dy all over the x. This is equals to, use this power to multiply anything that is here. So this is n times a is an x raised to the power of n minus 1. As I was saying, I said this is the formula for differentiation. Are you following? Do you understand? This is the formula for differentiation. So let's proceed further to consider some example. Okay, what if, assuming you have y equals to at raised to power n, it means we have to differentiate this function with respect to what? T. True or false? Yeah, it's true. Why? Because the independent variable here is what? Is t. So it's going to be our dy all over the t is equals to, use this to multiply whatever that is here, a n t raised to the power of n minus 1 is the same formula for differentiation. So far, so good. Amen? Are you following? Do you understand? Please, as you are here, I want you to like, and don't forget to comment. I want you to like. You can send me stars too. Okay, so let's proceed. Let's fix idea with one or two examples, then we'll move further to consider. So if you are asked to, if y is equals to 2x raised to the power of 3, then find dy all over the x. So this implies that you don't need the prophet to tell you, you just apply the formula here. We write solution, amen. Y is equals to 2x raised to the power 3. You can now see that, what is your a here? 2. What is your n here? Is what? 3. So we are differentiating with respect to what is here? X, right? So our dy all over the x will now be equals to, use this to multiply 6x raised to the power of 3 minus what? 1, true or false? Then the final answer will now be dy all over the x is 6x raised to the power of, 2. Raised to the power of 2. Any question, please, before we proceed? Do you have any question? Any question? So now we want to consider exponential functions. So if now you are asked to differentiate y equals to x, so the power here, there is an invisible one, true or false. So it means our dy all over the x is equals to, use this one to multiply invisible one here, it's the same thing. So here we now have the x raised to the power of 1 minus 1, then our dy all over the x is equals to x raised to the power of what? 0. True or false? You know, in mathematics, most especially in indices, anything raised to the power 0 is what? Is 1. So whenever you differentiate x, it's going to give you 1. Take note. Then another one is, let's say if y equals to 2x raised to power 5 plus 3x plus 10. When you come across, hope you are following, look at the board. Look at the board. So when you come across this Always take note that we have 2x raised to the power 5 plus 3x plus 10. Note that this 10 here is a constant. So whenever you differentiate a constant, it is 0, right? Whenever you differentiate a constant, it is what? 0. Why? Because you can now see that the independent variable is attached to this and this, but the independent variable is not attached to this. So even if they now write 10t, note that this is not the independent variable. As long as it said if y equals to this, differentiate with respect to x, find the y over the x. So this is a constant. Take note. Is that clear? So if we are to differentiate this function, it means our dy all over the x here, this is n, this is a. So 5 times this 10x raised to the power of 5 minus 1 plus invisible 1 here, 2 of us, multiply 3 is 3x raised to the power of 1 minus 1. Already, this is 0. So it's not necessary. Do you understand? It is not necessary. Are you following? So this is 0. So it means that our dy all over the x is equals to 10x raised to power 4 plus 3x raised to power 1 minus 1, 0. Then our dy all over the x is equals to 10x raised to power 4 plus anything raised to power 0 is 1. So 1 times 3 is 3. This is what you are supposed to get. So far, so good. Any question? So that let's move further to, I'm going to teach you how to differentiate exponential functions. Is that clear? To differentiate exponential functions. Any question? Any question? No question? So you mean we can proceed, right? You mean we can proceed, right? Danzuma is telling me to take it again. You know what I mean? I said whenever you differentiate a constant, this term is a constant. Why? Because the independent variable is not attached to it. Do you see x here? No. So it's always a constant. So if you differentiate a constant like this, is always 0. Is that clear? I'm not talking about this constant and this one. These constants, the independent variables are attached. So it can never give you 0. Except we have constant of plus 10. Or plus 100 or like that, it will always give you 0. So if you differentiate this function, this is your n, true or false. Danzuma, please listen. This is your n, true or false. So use this n to multiply the constant a there, which is what? True or false. True or false. Danzuma, are you following? True or false is true, right? Yeah. Then 5 times 2, is it not 10 raised to the power of x? 10x raised to the power of what? 5 minus 1 plus 3x. Invisible 1 is here. So 1 times 3, 3. X raised to the power of 1 minus 1. Then here I said it's 0. True or false? So at this point, 10x raised to 5 minus 1, 4. Then 3x raised to the power, you are going to have 10x raised to the power 4 plus 3x raised to the power of 1 minus 1, 0. But you know that the indices, anything raised to the power 0 is what? 1. So here is supposed to be times 1. But you can now see that it's the same thing as 3. The y all over the x is equals to 10x raised to the power 4 plus 3 times 1. Is it not 3? That's woman. Are you following? Do you understand? So let's move further. Danzuma, are you following? Let's move further to consider more example. Joseph, Micah, you are just coming. Electrical student, you are just coming. Joseph, Micah. I'm not saying my electrical students. I'm not saying you guys. It's okay. So we can now proceed, right? Let us proceed to consider exponential functions. Let's proceed to consider exponential functions. Okay, yeah. So as you can see now, if y is equals to x raised to the powers of exponential 2x, then find the y all over the x. Yes. So we write solution. These are exponential functions. Y equals to exponential x raised to the power 2. So how can you differentiate this function? It's simple as ABC. I will open your eyes. Please, if I were you, listen. If I were you, it's the same approach you will use. Is that clear? Are you following? We are going to use the same approach. The same approach. Okay, look at it. This is exponential x raised to the powers of 2. So what you need to do is just consider what is here. Consider what is here. What is here? Just assume that it is x raised to the power 2. True or false? True or false? It's true, right? So according to the definition of differentiation, if you differentiate x raised to the power 2, what are you supposed to have? Is it not 2x raised to the power 2 minus 1? Which is the same thing as what? 2x. True or false? Because 2 minus 1 is raised to the power 1, but it's not necessary. So it means what you need to do, this function that you have differentiated, use it to multiply back this original function. How? So it means our dy all over the x will now be equals to, as we differentiate this, it gives us what? 2x. So use this 2x to multiply this function back. So it means 2x raised to the 2x times exponential x raised to the powers of 2. This is the final answer. That is all. Are you following? That is all. That is all. That is all. Any question? Before we proceed, any question? Any question? I'm not saying electrical student here. Any question? My electrical students, I'm not saying you guys. I'm saying one or two. It seems you people are not serious. True or false? So that is that. So we can continue, right? Okay. So let's consider another example again. If y equals to exponential 2t raised to the power 3 and find dy all over what? The t. True or false? Okay. So what are we going to do? chemical students, please don't forget your assignments. I gave you guys assignment and I said I need them here, two of us. So don't forget, it's very important, so that I'm going to record those who submitted online, the YouTube channel. Okay, so what we need to do, write solution, right? Y is equals to exponential 2t raised to power 3. So what are you going to do here? What are you going to do here? What are you going to do here? According to the first examples. According to the first example. According to the first example. Please like and share. Don't forget to comment. It's very important. Attendance. Okay, what are we going to do here? This is when we write it out. Both y is equals to exponential 2t raised to power 3. So it means if I were you, just focus on this. Two of us. It means this is how it is. So ordinarily, if you differentiate this function, you are going to have 6t raised to the power of 3 minus 1. Two of us. So it means 6t raised to 3 minus 1 is 2. So you use this function. Use this answer to multiply this. That is all. That is how to differentiate exponential functions. So now, what you need to do, it means our dy all over the t. Mind you, it is no more the x. Why? Because what is here is t. So take note, always take note. So here will now be this, as you differentiate this, it gives you this. 6t raised to power 2. Use it to multiply this function. So you write 6t raised to power 2 times exponential 2t raised to power what? 3. Is it difficult? Is this difficult? Please, any questions so far? Do you have any question? Please, do you have any question? Yes, no. Do you have any question? Yes, no. Any question? No, yeah. So let's proceed to consider more examples. Let us proceed to consider more examples. Let us proceed to consider more examples. Okay. Yeah. Another example is if y is equals to exponential sine x. You know, differentiating trig functions. If y is equals to sine x, take note that if y equals to sine x, your dy all over the x is equals to cos x. Take note. Then if y equals to cos x, your dy all over the x is equals to minus sine x. Take note, it's very important. If y equals to tan x, your dy all over the x is equals to sec square x. Take note. Then if we have y equals to sine 3x, our dy all over dx is equals to, what is here? 3. Use this 3 to multiply. If you differentiate sine x, cos x, true or false? So use the 3 to multiply it. So it's going to give 3 cos 3x. Likewise, if y is equals to cos 4x, is the same thing as you differentiate cos x. What you get is minus. So it's going to be minus, what do you have here? 4 sine 4x. Then the same thing applicable if we have y equals to tan, let me say 1 all over 2x. If you differentiate tan x, what are you supposed to have? Look at the board very well. Take notes, because we want to. So you are supposed to have sec square x, right? So what we have here, half. Use it to multiply this, then put back this. So it means we have dy all over dx is equals to 1 all over 2 sec square 1 all over 2x. So take note of all these things. Is that clear? Take note. I want you to take note. Please don't forget to share after the class. I will be very grateful. So if you agree with me, so let's consider this. It means our y solution, y is equals to exponential sine x. So as it is the same approach, as we differentiate this, it gives you cos x, true or false. So what we need to do, our dy all over the x is equals to, use this, if you differentiate sine x, you have cos x. Use it to multiply this function. So cos x exponential sine x. Is it difficult? Please look at it. Is it difficult? Yes or no? Is it difficult? No, it is not. So I can claim this. Then we solve more examples. Okay, so let's look at another example. If y is equals to exponential 3 cos 4x, amen, then you are asked to find the y all over the x. Amen. It's simple as ABC. It is very simple. It's not difficult. Very simple. Please like, share. Okay, so let's consider this solution, right? Y is equals to exponential 3 cos 4x. So this means our dy, you don't need a prophet to tell you. You can tell somebody the answer, true or false. Just come here, look at it, just concentrate on this function. 3 cos 4x, true or false. If you differentiate cos x, you are supposed to have minus sine x. But here we have 3 cos. Then if you differentiate cos 4x, you are supposed to have minus 4 sine 4x, true or false? But now we have 3 cos 4x. So if we are to differentiate 3 cos 4x, know that there is a constant which is 3. So you use this 3 to multiply this 4. You are going to have minus 12 sine 4x. So you use this to multiply the function. So the answer will now be minus 12 sine 4x exponential, amen, exponential 3 cos 4x. This is how to differentiate exponential functions. Amen. Any question? Any question? Do you have any question? Divine, although you are just coming, I know, electrical students, you people are not serious. You people are not serious at all. Okay, so if you agree with me, our time is almost up. I'm going to give you guys assignments now and collect it in the class. I'm going to give you guys assignment now and collect it in the class. Okay. Assignment. One, if y equals to exponential 3t raised to the power 5 plus 4t squared plus 1, find the y all over the t. Then 2, if y is equals to exponential 1 all over 3 times 2 all over 7x, find the y all over the x. Okay, I want you to solve these 2 questions. Assignment. Write your number, write your name, very important. Then you submit it in class. Those that I have on Monday, Tuesday, Wednesday, and Friday. Class 9 p.m. to 10 p.m. 1 hour. Very important. Please try that. Please take note of this assignment. You are submitting it. Those who I have class with on Monday, Tuesday, Wednesday, and Friday, respectively. So try and solve this. Is that clear? Then don't forget our Monday class 9 p.m. to 10 p.m. Try and inform others. Thank you. Do have a wonderful weekend. Love you guys. Bye-bye.